Okay, so today we're going to talk a little bit about the homework for section 2.1 for module 1 in our functions and modeling class. We're going to talk a little bit about x-intercepts and zeros of functions. And this is a lesson where the vocabulary is very important, because this question, for example, here asks you to solve the equation for f of x equals 0, then find the x-intercept of the graph, and then define the zero of f of x. And it sounds like there's 3 different questions, but in reality, all 3 of these questions are going to be solved exactly the same way. Let's talk about why that is for a second. If you have a graph, it does something like this. Okay, this point right here is called the x-intercept of our graph. The x-intercept is the point where we cross the x-axis. And if we think about that point, you know, for example, this one might be over here at 2, 0. The key thing to remember here is that this is always going to have a y value of 0. And remember, when we write this function notation statement, f of x is our y in this, right? So this, what we're looking for here is where y is equal to 0. That is going to be the x-intercept every single time, okay? And another word for the x-intercept is the 0 of our graph, because it's where our function is equal to 0, where our y value is equal to 0. So all 3 of these questions are really asking us the same thing. F of x equals 0 is the point where we cross our x-axis. The x-intercept of the graph, still the point where we cross our x-axis. And the 0 of f of x, still the point where we cross the x-axis. You want to be comfortable with any of those phrases. They all mean exactly the same thing. We use them interchangeably. Okay, so let's look at this question and solve it. So if we're going to work through this, f of x equals 4/3 x minus 8. What we're going to do first is we're going to find the solution to f of x equals 0. So we're just going to start by plugging 0 in for f of x over here, and then solve. Okay, and we do have a fraction in here. So if we're going to solve this by hand, we would start by moving this 8 over to the other side. Okay, and then what I would do next is I would just multiply by the reciprocal of this fraction. So just flip it upside down, multiply by 3/4. And if you do it to one side, you're going to do it to both sides. Okay. And the reason why that works is the 3's cancel, the 4's cancel, everything is gone from that fraction on the right, just leaves us with an x over here on the right, which is what we're going for. We're trying to solve for x. On the other side over here, think of that like 8/1, and then look for common factors on top and bottom. So 4 goes into 4 once and 4 goes into 8 twice, right? And then we just have a bunch of 1s on the bottom. So 3 times 2 is 6. So 6 is going to be our answer there. So 6 is the solution to f of x equals 0. And like we were talking about, that is also the x-intercept. And that's also the 0 of the function. This asks for an integer or simplified fraction. One word of warning about this, it just says an integer here. Sometimes they might ask you for an ordered pair that represents the 0 or the x-intercept. So if that was the case, then our ordered pair would be 6 and 0, because that's how we got this, by plugging 0 in for y. Okay. So you want to be comfortable with all of those phrases. If you're asked to find the x-intercept, we're going to plug 0 in for y and we're going to solve. We can also ask you to solve a similar question graphically. Okay, it says that this is the graph of y equals f of x. It tells us that the 0 of this is equal to 10. So that tells me that this point right over here is 10 and 0. Anytime we're given a 0 or an x-intercept, we know the y is always going to be 0 there. Okay, and then it asks us, what's the x-intercept of the graph? Well, again, there's no work to this. It's just making sure you understand the vocabulary and what we're talking about here. 0 of a function and the x-intercept of a function, we can use those interchangeably. So if the 0 was 10, the x-intercept is also 10. Okay. And the solution to the equation f of x equals 0 is x equals 10. So again, all of these phrases are going to refer to the same thing. We'll use them in different situations, and you want to be comfortable with the fact that all those questions are all those phrases are kind of interchangeable. They all mean the same thing. So the second part of this lesson is about working with formulas and manipulating formulas and using them to solve problems. We do have a couple questions like this where we just give you a formula and then we ask you to solve for a particular variable. So it's important that we remember what this kind of a statement means. If we're asked to solve for a variable like t, what that means is we're going to work towards getting that t on one side by itself. So this is a problem where your calculator is really not going to be helpful at all. It's one that we kind of have to do this by hand since we're working with a bunch of variables here. So we just want to kind of work towards getting that t by itself on one side. So the first thing I'm going to do is get rid of this j, and j is multiplied times that whole parenthesis. So if I divide by j on both sides, I'll cancel those off and get us closer to having that t on one side by itself. And, don't make this harder than it is. We're dealing with a formula. You just can't do much with different variables like this. So you're just going to have two variables in what you've got so far. So again, I'm working towards getting this t by itself. So I'm going to get rid of this 1 next, move it over to the other side, subtract it from both sides. Okay. Again, working towards getting that t on one side by itself. And then finally, just going to divide by r on both sides. And I would just stop right here. There's some simplifying that you can do if you want, but I think this is fine. And again, you're going to have a bunch of variables in your answers to questions like this. That's okay. It's part of the process. We just can't simplify it because we're working with a formula. The reason why we do this is if we're going to plug a whole bunch of values into this over and over again, and try to find t values, we definitely want to have a formula that's already solved for t to work with. Okay. So next we're going to use some formulas to solve some different application problems. Our formulas for this section are going to be pretty straightforward, and but if you haven't studied them in a while, you might need a refresher. Like this one right here, we're going to have to calculate the average of something. So it says here to get a B in math, Alexandria must average 80 on 5 tests. Scores on the first 4 tests were 83, 73, 84, 79. What's the lowest score she can get on the last test and still get a B? So the key thing to understand here is that in order to average some number of items, what we want to do is we want to add those up and then divide by the total number of items that there are. So in this case, we're going to take our 5 test scores, one of which we don't know. So that's going to be our variable. So 83 plus 73 plus 84 plus 79 plus our unknown final score, which I'm just going to call X. We're going to take that. We're going to divide it by the number of tests, which is 5. Okay, that'll give us the average for our tests. And we want that to be equal to 80. Okay, so this is going to be our calculation. And again, if we want to find an average, add up all your things, divide by how many of those things there are. Okay, and now this is the equation that we're going to solve. So to do that, I'm going to start by getting rid of this 5. So since it's divided, I'm going to multiply by 5 on both sides. Next, I'll clean this up by just adding all these numbers together. So we want to add 83 plus 73 plus 84 plus 79. I got 319. And then finally, we just want to get that X by itself. So we'll move this 319 over to the other side. Gives us 81. Okay. So anytime you're asked a question about the averages, add them up, divide by how many there are, and then solve based on that. You'll also have several questions in this section about calculating sales tax and the like. Okay, so the idea here is when we have an automobile, that total price includes a 5% sales tax. Okay, what we're going to do is we're going to take the price of that automobile, and we're not given that value here, so I'm just going to call that X. Plus, I'm going to take my sales tax. Anytime we're doing math with a percentage, our first step there is really to change it to a decimal. So this is going to be like 0.05. Okay, so I'm going to take my price of my vehicle plus 0.05 times that price again. Okay, that's going to give me my total price, which is 27,914. Okay, and this will be the equation that I'm going to solve. And what's going to happen over here is I set it up as two separate pieces. Once you get comfortable with this, you know, what's going to happen with these is I'm just going to add them together. I'm going to get 1.05 for that. That's going to be the same every time. It's going to be 1 for the full price plus that sales tax percentage changed to a decimal. Okay, and then we're just going to solve from there. So we'll just divide by 1.05 on both sides. Throw that in your calculator. I get X equals 26,584.76. Now be careful here, because you might just put this 26,584.76 in and hit enter and assume it's correct. But this is the value of the car. X is the value of the car. What it wants here is the amount of sales tax instead. So really, that is just this piece right here. That's what we're looking for. Okay, so I need to take this, multiply it by 0.05, and that should give me the sales tax. So make sure you're answering the question that's asked. It's a very important part of any of these application problems. We'll do a lot of them over the course of this class. So it's important that you're making sure that you're answering the question that the problem is asking. So in this case, I put that in my calculator. I get 1329 rounded to the nearest dollar. So we're just going to go with 1329. Okay. Okay, so hopefully that's enough to get you off to a good start for this section 2.1 homework. Please don't hesitate to let me know if you have any questions at all. Y'all have a nice day.